In this video, we're going to look at radical expressions with different indices. To simplify radicals or quotients with different indices, we need to first convert all radical expressions to exponential notation. Next, when the bases are identical, subtract exponents to divide and add exponents to multiply. This may require finding a common denominator. And lastly, convert back to the radical notation and simplify if possible. In this exercise, we need to perform the indicated operations and simplify. Assume all variables represent positive real numbers. Let's take a look at root 2x to the third y to the third times cube root of 4xy to the second. We can rewrite this as 2x to the third y to the third all raised to the 1/2. Multiplied to 4x y to the second, all raised to the 1/3. From here, we need to get a common denominator. So I'm going to multiply the first fractional exponent by 3/3 and the second one by 2/2. This will give me 2x to the third y to the third raised to 3/6. The second grouping will be 4x y squared raised to the 2/6. Now that our bases of the exponents match, we can think of this as the 6th root of, and now we need to distribute that exponent. So I have 2x to the third y to the third raised to the third. And in the second grouping, I have 4xy squared raised to the second. From here, I can distribute that 3 to each factor inside the grouping. When I do that, I'll have the 6th root of 2 to the third x to the 9th y to the 9th times 4 to the second x to the second y to the 4th. I'm simply distributing that 2 as an exponent to each factor separately. Now I need to think about if I can combine any of these factors. 4 to the second, remember, is 2 squared, 4, that's 4, raised to the second. So that would be 2 to the 4th. Double check that. 16 would be 4 squared. 2 to the 4th is also 16. So we can make that work. That's equivalent. Let's rewrite this as the 6th root of 2 to the 4, 5, 6, 7, x to the 11th, y to the 13th. And then from here, we can decide what will come out of the radical and what will not. 2 to the 7th comes out as a 2. And we have a 2 in the radical left. X comes out as a 1 with a remainder of 5. And y to the 13th will come out twice, and y to the 1 is the remainder. Now let's look at part B. We have a 4th root of a squared b multiplied to the cube root of a squared b minus the 5th root of a squared b squared. Let's distribute the first radical in. We'll have the 4th root of a squared b times the cube root of a squared b minus the 4th root of a squared b times the 5th root of a squared b squared. We need to get a common index. A squared b raised to the 1/4 times a squared b raised to the 1/3 minus a squared b raised to the 1/4 times a squared b squared raised to the 1/5. I need a common denominator between 4 and 3 and 5. Looks like it's going to have to be 60. That will be 15 over 15 for the first one, 20 over 20 for the second one, 15 over 15 for the third grouping, and 12 over 12 for the last one. This will give me a lot of work. A squared b raised to the 15 over 60 times a squared b raised to the 20 over 60 minus a squared b raised to the 15 over 60 times a squared b squared raised to the 12 over 60. Now these all have the same index. It's 60. And the exponent is 15 on the first grouping, 20 on the second. So I'll have a squared b to the 15, and that's multiplied by a squared b raised to the 20th, minus, now we need to keep track of this. This is a separate grouping, so minus the 60th root of a squared b raised to the 15th times a squared b squared raised to the 12th. Let's see if we can simplify this further. This will be a to the 30th, b to the 15th, times a to the 40th, b to the 20th, under the 60th root, minus the 60th root of a to the 30th, b to the 15th, times a to the 24th, b to the 24th. In the first radical, I'll have the 60th root of a to the 70th, b to the 35th, minus the 60th root of a to the 54th, b to the 39th. In the second radical, nothing will come out nicely. In the first radical, we can take out an a. That will leave me a 60th root of a to the 10th, b to the 35. And minus the 60th root of a to the 54th, b to the 39th. Now let's look at division. We have the 5th root of a to the 4th b and the 3rd root of ab in the denominator. Let's see if we can get a common denominator. Let's see if we can reduce this fraction by building up each grouping. So I have 1/5 as the exponent in the numerator, a to the 4th b raised to the 1/5, and ab raised to the 1/3. I would need to build up the numerator's exponent by 3 over 3 and the denominator's exponent by 5 over 5. When I do that, I'll have a matching root or index of 15. So rewriting this, I'll have a to the 4th b raised to the 3rd over a b raised to the 5th, all under the index of 15. So the 15th root of a to the 4th b raised to the 3rd over ab raised to the 5th. I'm going to encourage you to pause the video and see if you can simplify this from here, and also try d on your own. Simplifying this, we have the 15th root of a to the 12th, b to the 3rd, all over a to the 5th, b to the 5th. We could reduce this. It would be the 15th root of 5 a's would divide out, and we'd be left with a to the 7th and in the numerator, and 3 b's would divide out, and b squared would be in the denominator. Go ahead and try part D on your own. This concludes the video.